Okay, let's see what are what the dictionaries are. Okay, so as of now, we have been learning about the sequences in Python, right? So sequences in Python means, let's say you have something like one, let's say X, Y, Z or something. So first element will have an index of 0, second element will have an index of 1, third element will have an index of 2, and so on and so forth, right? But, and if you want to simply fetch them, you will be using the index for that. But now we will switch the gear and talk about the mapping, right? Mapping in Python. So if you're similar with some other languages, you might have been known about the hash table. So dictionaries are nothing but the kind of a hash table. So for every value, we will have a key, right? So key value pair is called the dictionaries in Python. Okay, so what we'll see how do we create dictionaries, access the dictionary objects, and the nested dictionaries maybe, and also basic dictionary methods. So what are the mapping first? So mappings are nothing but the collection of the objects, stored by a key, right? So like every element will be stored by a key. So as of now, we do not store anything by, right? We just store them, and then whatever place it takes, if it is first or second or third, and based on that, we will give them a simple index, right? Whether or not it is a list or it is a string. So we do the same for both the cases, the list and the string. Right, but in dictionaries we will be using this idea of the key and value pair, that is the hash table. So what are the mappings? Mappings are nothing but the collection of the objects stored by a key, right? Unlike the sequences that store the objects based on their relative positions, right? So I talked about the relative position, means the first element is something. If your element is the second, then you will automatically get an index of 1, right? So that in there we are simply what doing, we are simply doing nothing but the storing the position based on the relative position, right? So this is important discussion, since the mapping won't be retaining any retain any order in this case. Okay, I'll discuss about that as well, why the ordering does not make sense in case of dictionaries. Okay, let's create dictionary. To create dictionaries, we'll be using this curly brackets. Okay, let's say you have sorry, let's say k1 is the key, corresponding value is this, and then a comma. Let's say 1 is the key, corresponding value can be 100. Let's say key is the key, and the corresponding value is value, right? So on and so forth. X is the key, value is a list. Inside this list, you have a list, a dictionary, a string, like this itself, right? See, this is a dictionary, right? So what we have done, we have created a dictionary, right? This dictionary has key value pair. So this is the first key value pair, this is second key value pair, this is the third key value pair, this is the fourth key value pair, then the final key value pair. Okay, so every key value pair will be divided by this column, right? So before the column there will be key, after the column there will be the value, and the key values can be anything. So in this case, you see, key is a string, value is a integer, key is a number, integer, value is also a number, key is a string, value is also string, key is a string but value is a list. Right? So it can be anything. So I would generally suggest, let's say you can also create a dictionary where key is float, but it's not suggested, there is no meaning of doing this, right? You can simply have the keys, you can simply make the keys only, you know You can make the keys only integer or the strings. That's it. There is no make sense. Does not make sense of making the keys as decimal or anything else. Right. So the first thing is the key, and then every key pair, key value pair will be separated by comma. Right. See the way you separate the comma by comma in the list. Right. So for each value, see, we are concerned about storing the value only. This, this, this. Right. We are not concerned about what are the keys and all. But if you are using the dictionary as a data structure, so we'll be having the keys, corresponding keys, and we have to know them. Okay. So this is how you create a dictionary, right? I talked about the dictionaries, the keys can be anything, the values can be anything, literally, right? How do you fetch them? You will be fetching this exactly the same way, right? The way you do the indexing, in place of index, you'll be writing the key. So let's say if I write K1, what will I get? This particular value, right? If I want to fetch, let's say value, what should I put? What should I do?
Key.
Key as a key. So D of
key, sir.
right? So I've got value, right? So that's how we do it. Now let's say I want to get this E out of it. This E. What do I do now?
D of hello.
Sir,
Yeah.
D of X.
D of X. Okay. So when we do D of X, what will we get?
5.
No.
So 5, then we write sir 5, sir. After
Okay,
X, we
5.
write 5,
Okay.
then 1.
Then 5. And then once again do the indexing, right? Then 1. All right, we've got E. Correct. That's very, very great. So let's see, what do we do? Let's understand how are we doing this actually. So let's say when we do D of X, what are we getting? We are getting this list. So since this is a list, you can consider it as a normal list like L, L1, L2, L, whatever. And then you can do once again indexing on this. Now, if you want to fetch this hello out of it, you can get only E if you fetch hello first. So how will you fetch hello? Either you can do -1 or 5. So you've got hello now. Once you have got hello, so this is what? This is a string, right? You can do everything. Like if you even do a dot upper, you will be able to get the uppercase, right? And if you want to make change, so you can simply reassign this. Now, if you check your dictionary, so this particular thing is in uppercase, right? So wherever I change it, I just reassign them, right? So yeah, we were here. So let's say we have got hello. Now, if I want to get E, so once again, this is a string and we can also do the indexing in the string as well. Right? And if I do 1, I'll get the E. My idea is to tell you that, let's say if you're doing something here and it is returning, so treat it exactly like that. So if it is returning a list, treat this whole thing as a list. If this is returning as a, if this is returning a string, a list, treat it as a list. Treat this whole thing as a list. All right, that's what I'm saying. Okay, got it. Yeah, okay, great. So these are the pretty basic things about the dictionaries. Okay, so you can also create an empty dictionary by using this empty, this particular thing that will create an empty dictionary. So you see, how do we add values into this, right? Or how do you change values? If you want to change, can you change? So you can change. For example, let's say I'm fetching this K1, right? So D of K1. Currently, D of K1 is what? 231, right? I want to make it 222. So I will reassign it a new value. The way you saw, it will be changed. Now you see it is changed. K1 is equals to 222. Okay. And so we have changed them. So D of, let's say, D of 1. So we've got this. All right. Let's say if you want to add something, right? So if you do the same way, right? So it will change because this key is already there. If you want to add something, right? So you have to find out the new key value pair. So let's say the key is key 2. Let's say the key is K2 and value is, let's say, something called 44. Right. If you run this, there is no K1 here, K2 here. So it is not going to update. If there is no K2, then it will add. So if you check D at the end, see this K2 44 has been added as a key value pair, a new key value pair into this dictionary. All right. Got it?
Sir.
Yeah.
So what if we add again K2?
It will not add. It will just see if K2 is already there. What it does? It tries to update it. It tries to update it.
Like sir, like we saw different cases in list, no sir, like adding like list members, like I mean the items or items in the list like 1, 1, 2, 3, 4. Like we have any repetition here in the dictionary?
So okay. Here, what we are doing here? How did I tell you that it will update? It will be updated in this case, right?
Yes sir.
So the same thing is there. If the key is not present, then it will add. If it is already present, and if you are running the same thing, right? If you want to see what you are saying, that's a different scenario. If you want get it repeated, just change the key. Let's make it K3 and check now. K2 has 44 as well. K3 is 44 as well. The main thing is the value, right? If you are storing the same thing in a list, the same data in a list, so you will not be storing the key, you will be storing the values only. And see, you have repetition 44, 44. The key is just another way to fetch that particular value. Simple. That's it. See, let's say you have a list, right? L is equals to 1, 2, 2, and 2, let's say. So all these two numbers are 2, right? But their index are different, right? Isn't it?
Yes sir. Yes sir.
So their keys will be different. Simple. Values will be different. Same. Got it?
What if keys are same sir?
If keys are the same, how come the keys can be same? If keys are the same, then it will update the same value. And if it is the same value, then it does nothing. You are doing nothing by running this again and again. You are actually updating the value at position at the key K2, but you are updating with the same thing. So it does not make sense.
The key name cannot be duplicate, right,
Sir.
Crash?
Yeah, what?
The key name cannot be duplicate.
No, key cannot be duplicate. That's exactly. Yeah, that's key cannot be duplicate. Okay, because see, key is nothing but a position. Key is kind of a key to search something. If you have same key, then the whole concept of key is not possible, right? You can get two values at the same key. That's not possible. Getting it? See, what I'm saying? See, what is the purpose of a lock? To lock the door, right? And if there is a salesman who is just selling the locks, then there must be one thing to secure everyone's home, that he creates unique keys. If he has duplicate keys, let's say person A buys a lock and person Z, or let's say person X buys a lock. Person A and X have same keys to their home. So person A can go to X's home, and person X can go to A's home, right? That's not the security breach. But in this case, that's not security breach. It means you cannot have a, that's a whole key thing is not possible then. So it is trying to update the whole value. So K2 will be the same. right? Key cannot be repeated. I hope you got it, right?
Yes, I got it.
Okay, great. There can be concept of nested dictionaries as well. It's nothing but dictionaries inside dictionary. So you have a key, let's say K1, and then you have a value instead of a value. Value is also another dictionary. So here we have K2, and then so on and so forth. If you want, you can also have another, another level of nesting. But yeah. Okay, in this case, tell me, can we have K1, K1? Can we do this? Is it possible to do this?
No.
Yes, sir.
Actually, it is. Why? Because these two are different dictionaries. This is a different dictionaries. It holds the value place in this outer dictionary. So it's possible. Let's say we have D1 is equals to this. And if you do D1 of, let's say, K1, then we've got this whole dictionary as a value. And if you once again do K1, then we've got 90. Okay,
Yes, sir.
great. um all right, so that's pretty much about the dictionaries. And I just the thing is, you have to understand the concept. Why what is the difference between the that list and the dictionaries, and why dictionaries are advanced? Because they are using another thing to store it. The searching will be very 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 easy in this case. Okay, all right. Somebody says, Sikashius, please repeat 19392. It's a nested dictionaries. It's a dictionary inside a dictionary. If you see, the value itself is a dictionary. Okay. And one more thing, please don't mind if I write sometimes wrong spellings. I am not very good at spellings in English. So um, please don't mind if I type something wrong, especially. Okay. So that's how you can use, the keys, sub keys, the nested keys, and so on and so forth. All right. There are some string dictionary methods as well. For example, if you do D1 dot, see, clear, copy, form keys, all there. Clear will, already what will do. Copy, you already know it will do the same thing. Form keys will actually form the keys. So if you simply see here, create a new dictionary with the keys from the iterable of the values they set you to this. Right? So let's say, oh. So here, whatever I'm passing, it is forming the key out of it. So let's look into the other methods. Get or items will select, will give you the items like the whole key value pair. It's not D1. Let's talk about the D. Yeah. So items will give you key value pair. Okay. So you see, this is the first key value pair. This is the second key value pair. This is the third key value pair, so on and so forth. This is the fourth. This is the fifth one. This is the sixth key value pair in the item.
So it's again a dictionary, right, sir?
No, it's not dictionary. It's another data set. Actually, it is a list. See, but inside a list, each key value pair are stored into a tuple. The tuple is something that I will come to later.
Okay.
So this is a tuple. Okay. Each key value pairs are stored in a tuple, and every tuple stores a key. Every tuple represents one key value pair, and this is a list of tuples actually. List of key value pairs. And if you do d dot keys, it will give you all the keys. If you do d dot values, so it will give you all the values. So it does not have a lot of methods actually. So you can just go and check the other methods as well. Okay, so that's the dictionary. Yeah, that's the whole thing about the dictionary. The main thing is just to understand what are the fundamental changes between the list, the sequence, the right. What are the fundamental changes from the list? So the fundamental change is we are making the time complexity for searching really fast by using another space variable. Okay. So next thing, let's move to the tuple. Yeah, tuple. I'm coming to that. So tuple is nothing but it's another another data structure. So tuple is a data structure like a sequence itself, right? Like a list. It's very much like list, right? There is only couple of changes, right? As you can see, let me just create a tuple. Tuple can be created by these parentheses, like the small curly, the small bracket. So this is a tuple, right? If you, let's say t is equals to this, and if you check the type of t, so it's a tuple. I didn't check for this, right? If you do type of d, you'll get dictionary. If you do type of l, you will get list. So type of L, you will get list, and so. Okay. So this is a tuple, and for the tuple, if you see t is equals to, yeah. So you can do the indexing, right? T of 0, you've got 1. T of 1, you've got 2. T of -1, you can do. T of, you can also do slicing as well. T of 1, 2, 3. So you can also do the slicing as well. You can also, do stepwise slicing as well, or column -1 to reverse this as well. So all of these you can simply do. Okay. It's pretty much similar to the list that we saw. The only change is this, that the tuples are immutable, right? Tuples are immutable. You cannot change once you have created a tuple, right? So let's say I have, so T is a tuple, right? Let's say if I do T of 0, and then if I want to reassign this to something called 0, let's say, right? So it says tuple object does not support item assignment. It's a similar error that we had found in the string that says string object does not support item assignment, right? Same thing is here in the tuple object does not support item assignment. All right. Yeah, that's the one difference. The tuples are immutable actually. Tuple are immutable, right? And the other thing is that tuple does not have a lot of methods. You can also create nested tuples as well. So see how many methods are in the tuple. So t dot, you see there is count and index method only. Like if you want to count the occurrence of something, or if you want to know the index of something. So there are only two methods, the count and index. So you might be wondering, why would someone use tuple instead of list if it does not have a lot of methods for our convenience, and it is just also does not allow the changing the items into that. So that's what its strength is, right? So to be honest, we does not use tuple as often as we use list, because we cannot change something once you have created as a tuple. So if you have this data integrity is one of the must thing. So if you don't want something to be changed once you have created, so you can use tuple for that. You can use a tuple in your objects that goes passes around multiple classes or multiple objects. So you can use data type for that as a tuple, that you will understand later. But yeah, this is one of the differences in the tuple. So where data integrity is must, you can use tuple for that. So whatever you put into that, that will not change the data of that into that. All right. So that's about the tuple. The next things are the set. The set in Python. Let's try to understand the set as well. What exactly are the sets? Okay, let's understand what are the sets. So sets are nothing but you might have gone to the set in high schools, right? In mathematics, you might have gone to set theory or something like that. So this is the same set, right? You can do you can create a data structure, right? Have some elements into this. So sets are nothing but the unordered collection of the unique elements, right? The collection of the unique elements in the set. Something cannot repeat, right? So let's say you have set function can be used to create set. Let's say 1 2 3 4 5 or something like that. So right, you need to pass it as a another object. So now it has created a set, right? You see. Right. You can also create a set by using this curly bracket as well. 1 2 3 4 and so on. So this is also a set. Since there is no column, there is no key value pair, it will not be dictionary, it will be a set. You can check the type of S. And you can see no value will be repeated. See, if you have right, so you see nothing will be repeated, right? It's only 1 2 3 4. Nothing is being repeated. Okay. All right. So there are once again add methods to add something if you want. Let's say s dot add. If you want to add something in the tuple, sorry, in this set. So you have added to that into here. So you can do a lot of those, set related things for this. For example, you can calculate the set difference. You can calculate. You can do union, intersections, all of these if you have two different sets, right? So, I mean, see, this thing is particularly not required. Basically, if you want to, let's say, eliminate the duplicate, then you can use set. You can create a set out of it. Let's say you have a list. List is equals to 1 2 1 2, like this, right? And if you use set and you pass this list there, so it will remove all the duplicates and it will give you only that particular unique values. Okay. So as I said, you can use this, let's say we have this S is equals to this, and let's call it S1. S2 is also something, let's say 4 5 6 7 8 9, like this. So we have S1. So we have S1 1 2 3 4 5 6, and we have 4 5 6 7 8 9 10. Now you can see if I do S1 dot let's say difference. So we are doing the set difference. So it will give you only what are the extra thing in the S1. And if you simply change it, so the set difference will give you extra thing in S2 now. So for this, you need to understand how set difference works. I'm not going to teach you set theory in here, but if you already know, you will be able to justify why we are getting these answers. Right? You can do S dot, let's say intersection. Like if you know what do we get between S1 and S2 as an intersection, so it will give you all the common values actually. So see 4 5 6 is common in both, so it is giving you the common, right? If you do the union, S1 dot union S2, So it will just combine all them and then get unique values out of it. Right. So it's a union of it. You can also calculate the symmetric difference between these two. Right. That's also something. So that's pretty much of it. Right, in the set theory, we will not frequently use the set theory. As I said, you'll be using just for eliminating the repetition, getting the uniques, or sometimes you may use this set difference or intersection. Maybe if you have some use cases, you can create your data into set, and then you can use these set difference or intersection, union, or anything you want. String cannot be, sorry, set cannot be, indexed. So basically sets are not meant for this. If you are using if you are going to use this, then ultimately you can go use some other data structure, right? Sets are not meant for this actually.
Sir, there is no index in set, sir.
There is no what? Indexing, yeah. Okay. Yeah, apart from this, we have some other things like Booleans. Right? Booleans are some other data type, I would say. So Booleans are nothing but we can see Python comes with Booleans, that is predefined true and false, that displays basically the integers 0 and 1, and also a placeholder called none. So we'll walk through a quick what about the this particularly Booleans. Yeah, just there are very few things. I'll just cover it up. Okay. So Booleans are nothing but, as I said, predefined true and false in Python. So if you write true with capital T and false with capital F, so it is nothing but the keyword you see, the changes color. So they are the keywords. So these are the Booleans actually. If you check the type of these, they are predefined. So these are the Boolean types. See, bool. Okay. And there is something called placeholder none as well. None means exactly nothing. And I'll just explain about it later as well, why this none are and where they are get generated. So where does these Booleans gets generated? These Boolean gets generated where you do the comparison, like, right? If you do some comparison, these Booleans will. So let's say if I do this, 3 is greater than 1, or 4 is less than 4 is less than, sorry, 4 is less than 1. So it is generating true and false, right? So these are nothing but the Booleans, right? You can also do, let's say, greater than equal to as well, like this. 4 is greater than equal to 1. So these are also some kind of or not equal to as well, right? 3 is not, let's say, not equal to 3. So it's false because 3 is equal to 3, right? If you see 3 is not equal to 2, then it will be true. There is also something called double equal to. Let's say when you do x is equals to 10 and when you do x equal to 10, there is a difference between these two. So when you are doing this, you are assigning it. We are assigning a value 10 to the variable x. In this case, we are comparing. We are comparing whether the value of x is equal to 10 or not, right? See, when we are comparing, then it is returning me true because the value of x is exactly 10 because we just assigned 10 before it. If you do this, it will give you false because now the value of x is 11 and we are checking with the 10. It's like this, right? So we got false. But if you do 10 equal to 10, then it will give you true. Got it? So that's how these Booleans are generated when you do the comparison operator. And that's pretty much of it, I guess. We talked about the nan as well, the none placeholder as well. So yeah, that's it. You can also store them into variables as well. For example, like a is equals to true or false or whatever. You can also do the and operator between these true and false, right? Let's go and learn about these and operators. How can you operate them on these Boolean data types in Python? These are the chained comparison operator. So that's it.